Hello, and welcome to the CA Ops MVS Best Practices video series. My name is Dave Gorsick from the Ops MVS team, and this video will provide you with a high-level overview of the CA Ops MVS REXX Host Environments that are available within your automated applications. It is part of the REXX Host Environments series of videos. This short video will provide a basic introduction to the host environments of Ops MVS, providing an overview of their functionality. Included will be a list of these environments, as well as a general coding outline that is needed to construct them within your automation. ZOS automation involves reacting to system events, from messages and commands to time-of-day events, and then performing a wide range of system tasks. Tasks such as issuing alert WTOs or messages, initiating system or database commands, sending emails, and much more. Generating WTO messages, from single-line messages to highlighted banner alerts, as well as issuing ZOS commands, will be primary functions within all your Ops MVS automated applications. This video provides an overview of various Ops MVS host environments that can be used within your automation to perform some of these system functions. Ops MVS REXX host environments are a key component of the product. They will be the go-to tools that are used within your automated applications when you need to perform common system tasks such as generating alert WTOs, issuing ZOS commands, triggering asynchronous programs, updating Ops MVS user databases, and much more. Additionally, various REXX host environments can be utilized to programmatically control and manage various Ops MVS facilities. Each host environment will have required and optional keywords, and most of them can be used in both Ops MVS rules and REXX programs. Host environments can be routed cross-system via the MSF component, allowing you to trigger system actions to a remote system, such as generating a WTO in System B from an application running on System A. Any generated output from the host environments is dependent on the command and the environment from which it was issued, meaning the address op or host environment used to issue ZOS commands will behave differently if performed in an Ops MVS rule versus an REXX program running in an Ops server. From the AOF environment, which will allow you to programmatically control the Ops MVS rules component, to manipulating system datasets via the Ops Dynam environment, you can see Ops MVS provides many host environments that perform unique system tasks as well as control and manage various Ops MVS facilities and components. Some of these environments may never be used within any of your automated applications, while others will be frequently used, such as the Opera environment. The Opera host environment will be used any time in your automation that you need to issue operator commands, such as ZOS and JES commands. As you will learn, the Opera environment can optionally collect and store command output into STEM variables, allowing your REXX programs to logically manipulate all types of command responses. Logic within your Ops MVS rules that are processing system messages, commands, end-of-memory events, etc. may need to spawn or trigger REXX programs to the Ops OSF server address spaces to perform some more complex automation or automation that requires waiting. The OSF, OSF TSL, and OSF TSP host environments will be utilized to dispatch these REXX programs to your different execution classes of Ops servers. The WTO host environment will be the primary tool used to generate single and MLWTO messages to a system console or log, as well as generate WTORs if interactive automated logic is needed within your REXX program. If you are new to CA Ops MVS or brushing up on the many tools in the toolbox, refer to the command and reference manual noted at the end of this video for complete details of all these Ops MVS host environments. Let's take a look at the standard syntax of utilizing all REXX host environments. Just as in TSOE-REXX, the address statement is used to change or set the destination of commands. Commands are strings that will be sent to the host environment specified by the address statement. This command string will provide the required and optional keywords expected by the designated host environment. The command string should always be enclosed in double quotes. While single quotes can be used to enclose command strings, using double quotes will simplify the code if any of the host environment keywords require single quotes. For example, coding address WTO would instruct the logic that subsequent command strings will be sent to the WTO environment, which is the internal code to Ops MVS that generates system messages. The command string enclosed in double quotes will contain the required and optional keywords for the WTO environment. In this example, the WTO command string contains the MSG ID, text, descriptor code, and route keywords needed for the environment to successfully generate the system message. Here are some coding examples of invoking Ops MVS host environments. This particular code is utilizing the address WTO host environment to issue a single-line message to the local system's master console. The command string for the WTO is using the message ID keyword to give this new message the ID of ops notify. The text keyword would be the actual message text, which in this case is the message text variable, and the con name keyword sets the ID of the local system's master console that is to receive the message. Note how this command string is substituting variable data that is obtained prior to the address WTO code. This will be a common coding practice used in all host environment commands. Like the previous address WTO example, this code is taking information from the current environment, but it will be generating an MLWTO or multi-line message to create more of a banner alert or informational message. The text var WTO keyword instructs the WTO code to issue an MLWTO versus a single line message as defined by the text keyword. As you will see, to generate an MLWTO, you will assign stem variables to each of the MLWTOs and then use the variable stem in the text var keyword, just as this code is using the MLW.txt variables. Note the MCS flags WTO keyword, one of the many keywords for WTO to do specific actions. In this case, this banner message is being instructed to only be sent to the system log. This particular code is instructing the opera host environment to issue a ZOS command. The address opera statement sets the opera destination, and the command string includes a required and optional keyword needed by the opera environment. In this case, the command keyword contains the actual ZOS command, and the no output keyword tells the code just to issue the command and to not collect and process the command response. Just as the previous sample used the address opera host environment to issue a ZOS command, this sample REXX program code is also using this environment to issue a DB2 command, but using keywords to instruct the opera environment to capture the command response. You will learn and see that the opera command capture keywords, such as command wait, stop response, interval, stop end, and command response keywords, will vary depending on the type of command response being collected. These trapping keywords, of course, instruct the opera environment of how long to wait for output, as well as ensuring that all response output is collected before continuing. After the command responses are collected, this code is manipulating a specific command out variable that was set by the command response REXX keyword, and then reacting accordingly. Within your Ops MVS AOF rules that are triggered by system message events, command events, end-of-memory events, time-of-day events, etc., you have the need to do actions or logic that requires waiting. Logic such as issuing a command and collecting the command response, issuing a WTR to an operator so you can process the manual reply, or allocating and manipulating system data sets. Since there's no waiting allowed in rules, you have to dispatch or trigger an REXX program to an Ops OSF server by invoking the OSF host environment. This example shows the logic of a message rule that is using the address OSF host environment to execute an REXX program in an Ops server. The address OSF statement sets the environment destination to OSF, and then the command string is passed with the required command to trigger an REXX program. This specific command string contains the name of the REXX program and the argument that is to be passed from the message rule, in this case the failing node as extracted from the issuing message. The OI string in the command text is the command needed to establish an REXX environment in the server, allowing this IST521I program to run as an REXX program. Thank you for viewing this video. For more detailed information about Ops MVS host environments and the complete Ops MVS product, click the information bubble in the top right corner to load the product page. From there you can go to the product documentation, visit the CA communities, or see the learning path.